Okay, so I got a student request for help with this topic, predicting the arrangement of electron groups around the central atom of a molecule, I think. Let's see what that says. Predicting the arrangement of the electron groups around the central atom of a molecule. All right, so we're going to be asked a couple different things. Pardon the noise behind me. My coffee's just finishing up now. We're given a molecule called methanone, which it turns out to be the same molecule as formaldehyde. It's a different name for it. So let me come here and say CH2O. Okay, it's a little bit ugly, but can you see it? All right. So the first thing we're gonna be asked is how many electron groups are around the central carbon atom. So in order to do that, we need to write the Lewis dot structure. All right. So what I'm gonna do is I'm gonna pretend like I don't know it yet. 1, 2, 3, 4. I have an oxygen atom, which is 1, 2, 3, 4, 5, and 6, and 2 hydrogens. Man, something's wrong with my pad here. Hydrogen is... Wait, let's go the other way. Hydrogen is... Right? You've done this before, because it was a prerequisite topic. So let's say that these 2 electrons make a bond, these 2 make a bond, and these 2 make a bond, and these 2 make a bond. I might need to recalibrate my board. So if that's true, can you see I'm going to have a carbon with a double bond, oxygen, there's the lone pairs which are not, right? That lone pair, you might say, is that lone pair, right? And the other one is the other one. You see that? So how many electron groups around here? All right, so we know from a previous topic that an electron group is either a bond. I'm going to have to readjust my board, I think. A double bond, a triple bond, right? Or a lone pair. These are my 4 kinds of groups, okay? So can you see if that's the case? Can you see I've got one group here, one group here, and one group here? Okay, so it looks like there's 3 groups around the central atom, okay? So let's go back over here, and we're gonna say there's how many electron groups are on the central atom? Remember, an electron group means a lone pair, a single bond, a double bond, or a triple bond. Let's go here and let's say 3. Now, if we have 3 electron groups, what phrase best describes the arrangement of these electron groups around the central atom? And it turns out that that is trigonoplanar. Okay, and I know that because I memorized it. All right, that's that might be in the sheet that you get to use for the final exam. So go look at that. It might be in there, and it'll be fun to use that table. But if it's not, yeah, you need to know it, okay? So 3, and it's trigonoplanar. So let's check this. We're going to get credit for that because I'm really good at this. All right, this is one of my favorite topics. All right, let's do another one. So this time we're asked about sulfur hexachloride. So it's SCl6. All right, so let's go over here and let's make, just a second here. I think I can make a new layer. Won't disappear that one. Wait, disappear that one and come over here to this one. Okay, so it was SCl6. What color am I in? Let's go to black. S and Cl6. Okay, so there's 6. That's 5. 1, 2, 3, 4, 5. And here's my 6th one. Okay, and all 6 of these chlorines have got 7 lone pairs of electrons, or not lone pairs, 7 electrons in their valence shell, right? And sulfur's got 6 because it's in group 6. Okay? All right. Well, now that I know it's got 6, I realize, hey, I've got a problem here. Problem is that these guys are going to all want at least one bond with the central atom, right? at least one bond. So if that's true, and you know what? I've got 6 of them. So I'm not going to draw all the electrons around all these chlorines, but they each have 1 electron that's unpaired, right? Agreed? Then they've got 3 more unpaired. They've got 3 more unshared electrons there. But if that's the case, there's going to be a bond. Oops, didn't leave room for that. There's a bond. There's a bond. There's a bond. 1, 2, 3. Oh, and there's a bond. Oops, that's a little ugly, right? But you see, this guy had 6 electrons around its outer shell, and each one of these chlorines, and there were 6 of them, all had an unpaired electron. So they each get to make a bond. So how many electron groups? Remember, groups are unshared pair of electrons, a single bond, a double bond, or a triple bond, right? So it looks like I've got 6 groups here. 1, 2, 3, 4, 5, 6. Okay. Let's go back over and put that in there. There are 6 electron groups around the sulfur atom. Okay, and what phrase best describes it? So I'm going to look on my sheet. I think it's there. It turns out it's octahedral. All right, and I just know that because I memorized it. Okay, now let's get that one right, and then I will do. Let's do one more, and then we'll see this topic go in our pie. All right, so now it's phosphorus tetrabromide anion. Okay, so if it's phosphorus tetrabromide, that means that. Let's wait. I want to get rid of that. Get rid of that. Boom. Let's go here. Phosphorus tetrabromide. So phosphorus is in group 5. So it's got 1, 2, 3, 4. Okay. Now, and then there's 1 extra electron. But let me draw this. 1, 2, 3, 4, 5, 6, and 7, because it's in group 7, right? So bromine's in group 7, so that's going to make, oh, and there's one, but it's a -1, so that means we've got 1 extra electron. I'm going to put the extra electron right, let's say right. It's got 1 extra, oh, there's 5, sorry. Phosphorus is supposed to start out with 5. And then phosphorus has 1 extra electron, which I'm going to put right here, right? So it looks like this guy's going to get to make a bond with, boom. This guy's going to get to make a bond with the lone pair here, or the lone electron there. This guy's going to get to make a bond with that one. This guy's going to make a bond with that one. Sorry if it's such an ugly picture. My marker's working horribly. Okay, so how many electron groups? Well, there's 1 electron, oops, whoops, just a second here. 1 electron group here, 1 electron group here, 1 electron group here. There's my 4th, and there's a lone pair of electrons, which makes 5. 5 groups of electrons, and if I have 5 groups of electrons around the phosphorus atom, which is the central atom, then it's going to be trigonal bipyramidal. Okay, and I have that memorized. All right, let's see what that looks like. Whoa, wait a second. Tetrabromate. Phosphorus tetrabromate anion. Just a minute here. I'm going to recheck. I said trigonal trigonal pyramidal. It's trigonal bipyramidal. I hope I said it right. Trigonal bipyramidal. Oops. Ah, crud. Okay, I got to do one more now because I put trigonal pyramidal. I don't know even know if I said it right, but it's trigonal bipyramidal. All right, let's do HCN. We're looking about the central carbon atom. So I'm going to come here. Get rid of that. Oh, I gotta. Let's go here, and it was HCN, right? HCN. Nitrogen brings 5 in because it's in group 5. 1, 2, 3, 4, 5. I'm going to put them all over there. Carbon brings 4 in. 1, 2, 3, and 4. And hydrogen brings 1 in, right? 1. So let's make some yellow bonds this time. Okay, so there's a bond. There's a bond. There's a bond. And there's a bond. So how many electron groups do I have here? 1, 2 electron groups, right? Because a triple bond makes an electron group. Okay, so let's come back over here. 2 groups. And that's going to make the compound linear. Hopefully I get that one right. All right. Okay. So it looks like we're done with that one. I've got 112 to go. All right, so hope that's helpful. Let me point out one thing that that students get mixed up on sometimes. You got to be careful when you're counting the electron groups. You're not counting all the electron groups. You're just counting them around the central atom, right? That one is irrelevant. It's not part of the question. Irrelevant. I gotta figure my marker. Okay. It's irrelevant. It's not around the central atom. Let's go back over here to our formaldehyde or our methanone, and it turns out this guy had, where am I here? This guy had like 1, 2, 3, 4, 5 groups total, but only 3 that were around the central atom. All right. Sorry about my handwriting here. I'll try to figure out what my tablet is doing wrong, and hopefully that will be a help to the students who are asking for it. Okay, get at me.